In this video, we will discuss the concept of relativity. Think of the following question: is relativity a modern physics idea? It is normal if you don't have the answer right away. But, relativity is not a modern physics term. Actually, Galileo Galilei developed what we call the Galilean relativity back in the 16th century. The idea of Galilean relativity is to find what is the relationship between two coordinate systems, each moving with respect to the other. It can be simply stated as follows. Suppose that you have two reference systems, S and S'. S' is moving with speed, u, respect to S. In such a case, it is clear that the positions x and x' of a particular event are related by. This equation is the Galilean transformation. It can be proven that the speeds follow a very similar relationship. This principle is very useful for the everyday experiences. Actually, the Newton's laws are based on this transformations. Now, in order to check the application of this concept, let's solve a simple problem. Example 1. If you're riding a bicycle at 10 km per hour, and your friend passes by, in the opposite direction, at 12 km per hour. What is the speed at which you observe your friend approaching? Could you solve it? Answer. First, we see that the speed of your friend is minus 12 km per hour, because the distance is reducing. Then we can write the speed equation as follows. Meaning that you observed your friend's speed v equal to 22 km per hour. Something important to note in the Galilean relativity is that the time is the same for both reference systems, no matter where they are. Think of this for a moment because this implies that if you put the reference system, S, in front of your computer, and S' at the other side of the galaxy, the time should be the same, even when they are billions of kilometers apart. This means that you could set a conference with an intelligent being at the other side of the galaxy to chat about the weather today. What do you think? Is this possible? An important piece of information missing here is that the Galilean relativity works fine only at inertial reference systems, that is, those that move at constant speed, including rest. Now, let's turn our attention to the relativity proposed by Einstein in 1905. Think of this. Suppose that you are waiting for your friend to pick you up, and then you see her driving toward you with the lamps of the car on. What is the speed of the light that you see, if the car moves at constant speed, v? In order to answer this question, we need to know what is the speed of light. But, did we know the speed of light in 1905? Well, Maxwell published a seminal work in 1865, in which he found that the electric and magnetic fields were part of the same phenomenon. Moreover, visible light is an electromagnetic wave oscillating in time. And it represents a small fraction of a broader spectrum called the electromagnetic spectrum. In the Maxwell's equations, that look like these, it can be deduced that the speed of light has a value of about 300,000 km per second in vacuum, using the well-known values of epsilon 0 and mu 0. Let's return to our previous question. What is the apparent speed of the light that you see? According to Galilean relativity, it should be the sum of the speed of light plus the speed of the car, right? Well, not necessarily. Albert Michelson in 1887 demonstrated two important things. The speed of light is constant in any direction that we observe, and, more important, that there wasn't a luminiferous ether in the space between the Sun and the Earth, meaning that light can propagate through vacuum. Then, what is the result of our original question? Here is where Albert Einstein appears. In 1905, he published a pair of papers describing a modification to the relativity concept, later known as special relativity. In his works, Einstein based his findings in two postulates. 1. The laws of physics are the same in all inertial frames of reference. And 2. Light travels in a vacuum with the same speed c in any direction in all inertial frames. Interestingly, in 1905, Einstein was not familiar with Michelson's work. Einstein's postulates have very important consequences. Time dilation. And length contraction. These concepts have very deep consequences in the way that we experience reality. For now, we can say that the way in which Einstein developed his special relativity theory produced another important result. That is, the speed of light is a speed limit for the interactions happening in nature. Meaning that, there is no way for an interaction to be instantaneous as the Galilean relativity states. Finally, in the case we were analyzing, we can see that the speed at which you see the light coming from the car lamps is simply the speed of light. Actually, this result is the same if the car is moving away from you. The speed of the light that you see is the same. But, we will discuss in more detail these ideas in the next video. Stay tuned.